Okay, so today we're clearing fractions and variables on both sides. What should we multiply by to clear all denominators? Okay, so how about Lauren? Can you complete this sentence for me? I would multiply by what to both sides? Because. Good. I would multiply by 8 on both sides to clear that fraction. Excellent. We're going to do this together. How about Dylan? What about this one? Okay, so if I multiply this side by 2 and this side by 2, if I multiply that side by 2, would that 4 go away? It would? So couldn't you multiply by something a little bit bigger so that the 4... So you would multiply by 4 to both sides. We could say because 8 divided by 4 is 2, and 8 divided by 1... Oops. And 8 divided by 8 is 1. And this one we could say because 4 divided by 2 is 2, and 4 divided by 4 is 1. All right, so you guys are going to do the next exercise. Think, pair, share. A's I would multiply by on both sides because, and then the next one, B, is going to say I would multiply by blank because. If you disagree with A, tell them why in a complete sentence. I want to hear those sentence frames. Go. Better. Okay, so let's see. How about Ariana? Ariana, why don't you complete this sentence for me? You multiply by what? 2. On this one? That would 2 would get rid of the 6? Not quite. Kaja, what do you think? Yes. If you multiplied both sides by 6, then the 6 would go away. Good. How about Michaela? Michaela, what about this one? Whoa, 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 whoa. Oh, but you don't have to do -8. You could just do 8. Good job. Oh, see, that's going to bug me. I got to change that color. I would multiply by 8. Good. Let's see. How about Samisi? About this one. By what? 30. Would 30 get rid of 4? 3. Would 3 get rid of 4? Would 4 get rid of 3? No. So what number would get rid of both 3 and 4? 12. Good. All right. Good job, guys. Let's move on. I need you to record your steps, so get out 2 sheets of paper, 1 for your homework, 1 for your notes, and get started on recording your steps, please. Let's look at this first one. So I have 1 divided by 2, and I have 3 divided by 4. So I'm going to multiply both sides of my equation by 4 so I can clear that denominator. So when I do that, because I don't need to distribute anything, right? So when I do that, I get, I'm going to break up 4 to say 2 times 2 over 1 multiplied by 1/2 k. Everybody see what I did there? 2 times 2 is 4. I just distributed the 4. 4 is positive, so I'm going to say plus. This time I don't need to break up the 4 because it's being multiplied by a constant that doesn't have a denominator. So it's just going to be 4 times -3 equals, multiply 4 times 2, and 4 times negative 3/4 k. Oh, this 4 should have a 1 underneath it, right there. All right, I'm going to go through and clear my denominators. 2 divided by 2 is 1. 4 divided by 4 is 1. Let's multiply. 2 times 1k is just 2k. 4 times negative 3 is negative 12 equals 8. Nothing left here except for negative 3k. Now I need to decide. So a little t up here, little table. Which one's bigger, negative 3k's or positive 2k's?
Positive.
So my k's are going to be on this side. The k's win over here. Numbers are on this side. Am I allowed to have numbers on this side? Andrew, can I have numbers on this side? What goes on this side? Variables. Is that a variable? No, so how do I get rid of it? Add 12. Ooh, let's change our color for this one. Gonna add 12 to both sides. That gets rid of it. Am I supposed to have variables on this side? No, so I need to do the inverse. Add 3k to both sides. I do that. I'm left with, let's see, these go away. These go away. I'm left with 5k's is equal to 20. We did that yesterday. If 5k's equals 20, what would 1k equal? 4. Or I could just divide both sides by 5. So 5k divided by 5 equals, break this number up. 5 goes away, 5 goes away, and k equals 4. Question? When I put this up, I don't know why it does that. It jumps back up. Okay, everybody good?
Yes.
Let's do another one. This time I've got 4 in the denominator and 3 in the denominator. Good. I'm going to multiply everybody by 12. So when I multiply 12 times 1/4, I better break up 12 so that I can cancel. Multiply this by 12, I get negative 2/3 y equals 3 times 4 over 1 times 3/4 and 3 times 4 over 1 times negative 1/3 y. All right. So 4 divided by 4 is 1, 3 divided by 3 is 1, 4 divided by 4 is 1, and 3 divided by 3 is 1. Let's simplify. What's left over here? 3 times 1 is 3. 4 times negative 2y, negative 8y, equals 9 minus 4y. I'm going to ask him to pick on Andrew again. Andrew. Gotta keep him awake, right? I've got negative 4y's on this side and negative 8y's on this side. Which one's bigger, negative 4 or negative 8? Negative 4. Why? Excellent answer. It's closer to 0 on the number line. So my y's are going to be on this side, and my numbers are going to be on this side. Numbers on this side, so what needs to go away? Or is it G?
Oh, Y,
It's
Y.
Y. Sorry, it kind of looks like a G. So I'm going to add 8 y's to both sides to get rid of that. That goes away. Add 8y to this side. Okay, I'm only allowed variables on this side, so what needs to go away? 9, so I'm going to add negative 9 to both sides. That makes this go away. I'm left with 3 and negative 9 make negative 6. 8y and negative 4y makes positive 4y. Finally, I need to divide by both sides. So 4y divided by 4, negative, I'm going to break this up. Did I divide both sides by 4? I did. 2's go away, 4's go away, and I'm left with y equals, what's left over here? No. There's a 3 there. 3 over 2. Negative 3 over 2. I'm sorry, is that what you said? I apologize. I thought you said 0 over 2. Questions on this one? All right, you guys try one. Try this one. Okay, so Mario, what was your first step? Okay. Oh, okay. So you chose not to clear fractions at all. What's our first step? Distribute. Is there anything to distribute? There is? Not yet. Second step, clear fractions. How do I clear fractions, Mario? Alex, how do we clear fractions?
And the opposite, or in the opposite?
Okay, so what's the opposite? What do we have in our denominator?
4/3.
Oh, I wouldn't multiply by 4/3. What do you think? Yes. There you go. Not by the inverse, but by the common denominator. And we only have one denominator, it's 4. So we're going to multiply both sides of our equation by 4. Remember that, Mario? Okay, so now I distribute, right, Levi? So when I distribute 4 to 3/4, I get 4 over 1 times 3/4 m plus 4 times negative 5. Then over here on this side, I've got 4 times, I should probably do 4 over 1, times 1/4 m. Let's fix that. Plus 4 times negative 1. Now let's go through and clear the denominator. 4 goes away, 4 goes away. 4 divided by 4 is 1. So now I'm just left with 3m minus 20 is less than, what's left here? Just 1m minus 4. Now I've got to figure out what I've got on each side. Which side has more m's, the right or the left? The left. So I'm going to put the m's on the left, and I'm going to put my numbers on the right. So if m's go on the left, I better move this m. Oops, my color didn't change. So I'm going to put m on this side and 20 on this side. These go away. These go away. I'm left with 3m's minus 1m is 2m's is less than 16. If 2m's is less than 16, what is 1m less than? 8. Good job, guys. Got this one. Try this one. All right, let's go with Celeste first. Celeste, what can I multiply everybody by to clear these fractions? Good. She says 6. You guys agree? So when I multiply everything by 6, let's distribute now. 6 times 2/3. So I'm going to write that 2 times 3 over 1 times 2/3 cubed plus 6 over 1 times negative 1/6 equals, let's see, let's break this 6 up. 2 times 3 over 1 times 1/2 q plus 6 over 1 times 5/6. Is that going to clear everything? Looks good to me too. So 3 divided by 3, 6 divided by 6, 2 divided by 2, 6 divided by 6. So 2 times 2 is 4q minus 1 equals 3q plus 5. Draw our little T over here. Which side is going to have the q's? Mario? You're very vocal today. Which side is going to have the q's? The left side? Why? Excellent. 4q is greater than 3q. Yes, Frankie? Can you wait just a minute? Perfect. All right, so if I want q's on this side, I need to get this 3 over here. How can I do that? How about Carlos? How do I get this 3q's out of here? No, if I want to get 3q off of this side, I would subtract 3q from both sides, right? We're just moving it. We're not multiplying, we're just moving it. So negative 3q, negative 3q. Carlos, how about this one? Add 1, add 1. That gets rid of my numbers off of this side and my variables off that side. Correct? So we're left with 4q minus 3q's is just q equals 6. Questions on this one, guys? Yes. All right, pencils down again. So this time I'm going to have to distribute first. So I'm going to go ahead and distribute 1/2 to everybody inside of it. 1/2 times 6 is 1/2. I'm going to break that 6 up to be 2 times 3 plus 1/2 times negative z over 1 equals z. And I do that, these automatically cancel, which that's nice. And I'm left with, these don't, that looks like a z. My bad. It's a 2. It's hard to have 2's and z's in the same problem. All right, so we're left with 3 over 1. Change my color. 3 over 1 plus 1 times negative z is negative z over 2 equals z. We still have a fraction. What should we do? Multiply everybody by what? 2. Good. When I do that, I get 2 times 3 plus 2 times negative z over 2 equals 2 times z, which is 2z. That gets rid of those 2's. Still okay, Levi? Yes. And I'm left with 6 plus negative z. That's what that is, right? 6 and negative z equals 2z. Which side should have the z's? The left or the right side? The right side should have the z's. The left side should have the numbers. How do I get the z's on this side? Add z to both sides. This is just a normal one-step equation now, right? Give myself a little tiny bit more room. It's not going to give me more room. And we're left with 6 equals 3z. If 3z's is 6, how much is 1z? 2. Right? Each z is 2. 2, 4, 6. Okay. Good job, guys. Questions on that one? That one was no different except for we just had to distribute first, right? Try this one on your own. All right, Levi, what was your first step? Awesome. So you distributed this. So you got 1/2 times 3g over 1 plus 1/2 times -2 over 1 is less than g divided by 6. So when you do that, those go away, and you're left with 3g divided by 2 minus 1 is less than g over 6. This one is -1. Because 1 minus times -1 is just 1. So how do I get rid of these fractions? Excellent. Multiply both sides by 6. Good job, Frankie. So when I multiply both sides by 6, I have to distribute it, right? When I distribute it, I get 2 times 3 over 1 times 3g over 2 minus, or I should say plus 6 times -1 is less than. Do I really need to distribute this? It's already right there, right? We don't need to do anything with it. So that's g. Let's see here. Might as well just bring this all the way over. There we go. Okay, so these go away as well, these 2. Now we're done with our fractions. So 3 times 3g is 9g, minus 6 is less than g. Where am I going to put my g's? On the right or on the left?
Left.
On the left. We got to move this one. So we're going to subtract g from both sides. And the 6 needs to go on this side, so I'm going to add 6 to both sides at the exact same time. 6's go away, g's go away, and I'm left with, what's 9g minus g? 8. Change my color again. 8g is less than 6. Well, that's not fun, right? Let's divide. 8g divided by 8 is less than, let's break that up, 2, 3 over 2 times 4. Does that work? 8's go away, 2's go away, so what does g equal? Our g is less than 3/4. Good job, guys. I don't think we need to go through this last one. I think I want you guys to get started on some homework. So let's look at this. There we go. What did you learn today?
How to variables on both sides.
Variables on both sides with
Fractions.
fractions. Excellent. How would you describe solving with variable on both sides? What do you think, Levi? What's kind of like that process? What do we do? When we have a variable on both sides, don't we need to
See which one the variable goes on.
see which side we want to put the variable on? Usually it's the one that's bigger, right? That's how we decide which side we want to make all of our variables be on. The person next to you is absent. How would you explain clearing the denominator, Frankie? Okay. You got to find something that you can multiply by so you can cancel everything out. That's a good way of explaining it. Good. On your assignment sheet, please write this in a complete sentence. The first step would be, blank because blank.
The teachers.
All right, good job today, guys.